Okay, so we're going to go over this test your understanding question here, kind of getting to the end of this idea of using friction and inclined planes. So a parcel weighs 10 newtons. So first thing to say with that one is be careful. 10 newtons means that the force down is just 10. Okay, I'm going to change that to that one there. Okay, so not 10G, just 10. So you need to watch out for that one. While we're here, let's do our triangle because we know we're going to have to do it anyway. So something like that. And then this will be 10 cos 30. We could also put R on, couldn't we, at the same time? That's it's not the best one ever. That's a bit more accurate, R. And we could also put on this one here. That would be opposite, so it's 10 sine 30. Okay, and then let's carry on from there. So it's a rough plane, so that means we've got friction involved, so let's not lose track of that one there. 30 degrees, horizontal force P, yeah. Okay, so let's break that one up. So that's going to be made up of sort of that and that together, isn't it? And that will also be 30 because it's like a Z angle, alternate angles. So this one then is going to be P sine 30. And then this one here, which is always a bit awkward, this one is going to be P cos 30. Friction, we leave friction until the end because it's not obvious yet where to draw it. It's in equilibrium, yeah, on the point of slipping up the plane. Okay, so there we go. On the point of slipping up the plane means it's about to go this way, which means friction will go against it. So this is why it's a bit awkward to draw, really, because you also need to now put friction in there. Okay, and it's mu r because it's on the point of slipping up. The normal reaction is 18. Okay, actually, I can do better then, can't I? I can do better than calling it r. I can just call it 18. The coefficient of friction is mu, so that's unknown. Find the value of p. So what do we do? Well, we'll get loads and loads of marks to start with, and we'll figure out what to do if we just write our equations. So 18 is acting away, so 18 is equal to P sine 30 plus 10 cos 30. And the parallel one is going to be that, what's the best way to write it? Maybe mu r plus 10 sine 30, because they're going the same way together. And then the other way is P cos 30. Okay, so that should be pretty much all we need to answer the rest of the question. So presumably it's going to ask us to find out mu and p. Find the value of p, find the value of mu. Okay, so I have to work those ones out because I don't have those calculations in front of me. So, well, if you look at the top one here, so that's just got one unknown in it, hasn't it? So if you did 18 minus 10 cos 30, and then you divide it by a half, which is so 30, you would get p. So p is equal to, let's type that one in now. So 18 minus 10 cos, just check I'm in degree, 10 cos 30 over, is it just sine 30? Yeah, just sine 30. So let's check that. I get 36 minus 10 root 3, which is the same as 18.7. So work out the value of p, yeah. And then I could even store that on my calculator, and mu r, now that's 18, isn't it? So mu will be equal to p cos 30, take away 10 sine 30 over 18. So let's just store that in my calculator. Yeah. So I'm going to do so P, and then yeah, cos 30 minus 10 sine 30 over 18, and I get 0.62. Okay, and remember, once I find this value, that's the value for the rest of the question. Okay, so if I have to use mu again, I'm going to reuse that value there. Okay, what happens in the next bit then? So the horizontal force is removed. So the horizontal force means P, doesn't it? The horizontal force is removed. Determine whether or not the parcel moves. So when forces are removed, we have to be prepared for the fact that like a lot of stuff is removed. Okay, so you almost need to sort of draw a new diagram and then just think if you're allowed to reuse anything or not. So if I just do a quick sketch, what can I reuse? I can reuse the fact that it's 30 degrees. The weight of the block is still 10, isn't it? So I could just jump straight to this. I could just jump straight to saying, well, that's still 10 cos 30. And that one there is still 10 sine 30. How about R? Well, do you remember saying in the previous video that when you change the forces that apply in a perpendicular way, it changes R? Because you're pushing down less, it means the R value doesn't have to do so much work. So the R value is now initially unknown. Okay, it's not necessarily 18. All the forces connected to P are gone. And friction we're going to come and think about now. So if you look at this initial diagram, the only force that's moving things down the slope is 10 sine 30. Yeah? So friction will definitely be going that way. Okay? Because there's no other forces involved. So it definitely wants to go down the slope. So the question really is, how does 10 sine 30 compare with mu r? If it's greater, then it's going to go down the slope. Okay? And if it's less, it means that the friction can withstand even more force and it won't move anywhere. So 10 sine 30 is just 5, right? Mu we said from before is 0.62. I believe it was 0.62, yeah. So what we need to do now is we need to find R. So the way to find R is to notice that R must be equal to 10 cos 30. Okay, and if I want an exact value for that one there, it's 5 root 3, or if you prefer, 8.7. So that's what the R value is. What about if we do, if we multiply it? So if I multiply 5 root 3 by 0.62, I get 5.37. So in other words, friction, yeah, so the friction is greater, so the maximum amount of friction is greater than the force down, okay, which is 5. So it does not move. It's not because friction is doing 5.37. The friction is actually doing 5, right? It's just matching it. But the friction can go up to 5.37. So unless this number here is greater, it won't move. Okay, so notice we had to draw a new force diagram there because the forces had changed, and then we just need to compare what's going on in a parallel sense.